right. Very good. Good afternoon, everyone. My name is Jens van der Wijngaarden. I am the Global Product Line Manager for our, what we call the reactive extrusion portfolio. And today I'll be talking a bit more on how to leverage the use of additives to improve the performance in recycled polyolefins. To start, I'll share a few words on Milliken as a company, for those who are not aware of who we are. So Milliken is a privately held company with a global headquarters in the US, Spartanburg, South Carolina. But we do have a very widespread global presence. As you can see, we are over 8,000 people worldwide and have over 70 global locations. The majority of that are production locations, so we are a manufacturing-driven organization. And we do have European headquarters and a few headquarters in Asia as well, where we support with sales offices and labs. Milliken originally was a textile company, but diversified a lot through the decades into a more widespread and broader activity company. So textiles is the core business originally, but we're also present in floor covering, healthcare, and I'll be representing our chemical business unit today, especially the plastic additives unit. As you can imagine, having a foot in a lot of different industries and markets, we do need to pay a lot of attention to everything that's going on a health and safety and recycling point of view, which is why we try to be at the forefront, or at least involved with a lot of organizations. Here's just an overview from our division where we try to play, even as an additive supplier. While we are not directly involved necessarily with recycling or the production of the materials, we do feel it's necessary to be involved across the value chain and collaborate where needed. At the top is our involvement with the Alliance to Prevent Plastic Waste, which is a very important organization, obviously. But we also have more regional organizations where we even work on setting up collection and sorting facilities for polypropylene, for example. So it is a bit more widespread, but we do believe that the value is there in being involved in the entire value chain. That principle we have been using for many years already on how to work in the market. So we are an additive supplier, but we work with everyone in the value chain, starting from the resin producers who use our additives, the converters who process the materials, recyclers, compounders, down to the brand owners to help identify what are the real needs for the materials that can be alleviated with additive technologies. What I'm showing here is not much of a breakthrough statement. I think everyone is well aware that there are a lot of market drivers, both consumer behavior and regulatory-wise, that drive a big increase in demand for post-consumer recycled, like you see in the graph that I borrowed from the Ellen MacArthur Foundation report on the commitments made by brand owners and retailers on how much PCR they will be including in their plastic needs in the coming years. Like we know from the last weeks and months, these are a bit of moving targets sometimes, which I can fully understand. But besides that, there are also a lot of technical gaps that can be considered roadblocks or bottlenecks for further implementation. And that's what we see a lot when in the market, that people who are converting polyolefins are struggling with some technical difficulties that we believe that additives will play an important role in. Not just our additives, but additives as a whole will need to play a very important part in polyolefins or polymer recycling in general. When we discuss all of these topics with the recyclers or people who commonly use recycled materials, we do see often common trends picking up again. On one hand, you have the processability. The reality is recycled materials do not process like virgin polymers. That's also fine because that can be overcome. And then, of course, productivity-related issues. All these virgin materials are designed for speed, high performance, while recycled materials do have a bigger bridge the gap. And on the other end, you have the mechanical performance of it all. As soon as you go through a recycling step without further additivation, your impact strength will decrease. You might have some stiffness issues, and that makes it definitely a struggle to incorporate high amounts of recycled polymers. Today I'll be highlighting two of our products with a focus on three specific aspects. One of it is how can we include more PCR, especially on the PP side, into your molded parts. On the other hand, like once you have done the incorporation, what's next? Can we also look further and reducing energy consumption, reducing your CO2 footprint, so beyond just incorporating PCR. And then finally, very specifically on recycled polypropylene, how can we boost the mechanical properties to a degree that we can include a lot more in your formulation. And we'll be talking about Delta Max performance modifier specifically and our ultra-fast solutions for AZP recycled. I'll start with our Delta Max technology. It's a very busy graph, I have to admit, so I'll explain it very simply, and then it will become a bit more clear. What Delta Max does, it basically plays with the inherent balance between the melt flow rate, so the viscosity of the polypropylene, and the impact behavior. Typically, we have a trade-off. The better the flow, the worse the mechanical properties, to keep it very simple. With the Delta Max technology, either in master batch form or in neat additive, we are able to shift that performance to a different part of the curve. So while increasing the melt flow, we can also significantly improve or change the impact behavior. We have a few products in the portfolio, but for the sake of keeping it easy, I split them out into two buckets. One is very much impact driven. That was the Delta Max A200 and i300. So there we really focus on the top end of the curve, trying to really improve the impact behavior while also offering some productivity increases via the melt flow rate. The other end, that's really viscosity modification driven. So really pushing the viscosity to a higher level while keeping the impact behavior where you need it and not seeing a drop in the performance. As you can also see, some of our products are a very cheerful orange color, which is inherent to the chemistry. However, we have not seen much issues given the coloring of most recycled materials out there. However, we do see a lot of trends in the sorting going more towards a natural ebony, light grayish color. So for that reason, we also developed a white colored version as the Delta Max F500. To clarify a bit what is the real value of that shift in performance, we selected two case studies with customers and partners of ours to give you a bit of inspiration on how to use these products. This first one is a case study we did together with our partners at Jelenia Plast in Poland. They were molding a very large storage container, rather complex mold, a lot of detail on the mold. They were already doing an excellent job in incorporating recycled PP into the formulation, but they struggled a bit with multi-sourcing. So they had RPP coming in from multiple sources with varying quality, and as a result, they could not push the PCR content to the highest level that they wanted, because then they saw all the fluctuation in performance. So we worked closely with them to develop a formulation containing the Delta Max technology, and as a result, we were able to significantly increase their targets as well. So as you can see, the overall PCR content was increased from 40% to 90%, so that's very impressive in my personal opinion. But while doing that, we were also able to significantly change the processing parameters. So it enabled them to reduce the processing temperature with 20 degrees C and get around 10% reduction in cycle time. So the faster you produce, the less energy you consume making parts, and the better your CO2 footprint as well. So that's one aspect. Another project was in collaboration with ExxonMobil. For this one, I'll go a step back and explain how you can modify the viscosity of PP in general, and then explain where the value of Delta Max comes. If you take a standard RPP on the market, it's a complete break, not too great impact in general, and a melt flow between 8 and 20, let's say around 12 to 14. The standard practice is viscosity modification is peroxide treatment. So when you do peroxide treatment, you get exactly what you hoped for. You push the melt flow, but inherently you will decrease your impact properties. When adding our Delta Max technology to really curbside PCR, we are able to go to that same length of melt flow increase while maintaining the impact. Why is that? That is because inherently PCR waste does not have enough rubber, which is the driving force behind the Delta Max technology. You really need that rubber present that you have in virgin PPs to boost the impact. But in the good case, we are able to keep the impact properties at the same level as that you had before. Now, what we discovered while working with ExxonMobil was that when you combine it with their range of exact polyolefin elastomers, you do see a synergy. So by adding the combination of the exact elastomers and Delta Max, we were able to increase the processing properties and get notch Sharpie, for example, to a level that was meeting the very stringent specifications of automotive compounding, for example. So here's a very specific formulation that we worked on together. It's a bit blurry from where I'm standing, but should be okay. The goal was to really go for an automotive compound with a high amount of PCR PP. So we started here in the middle. You have a very difficult to distinguish light gray box. That is your standard RPP that we used. Normal curbside waste, 100% PCR, about 15% polyethylene contamination. When we added the Delta Max on its own, that's the sharp blue curve, we were able to push out the viscosity to make it much better to process, but didn't really improve the impact, but that was expected. We kept it at bay, as was hoped. When adding the exact elastomers on their own, we get a good increase in impact, both at room temperature and sub-zero. But again, processing wasn't ideal, and impact was not yet meeting the requirements. And then the black curve is the combination of the two technologies, and that's where it really came to fruition, that the combination of the two technologies was an added value. So we were able to meet the impact requirements of at room temperature of an automotive compound. Even the sub-zero temperature impact was well increased, and you had a decently processable material on the injection molder. So 2 times more melt flow rate, and they kept the stiffness target of 650 megapascal. So all over, it was a decent, well-usable automotive compound in that aspect. Delta Max as a reactive technology is designed to push the limits further and expand the properties of your recycled PP. This is not needed for every application. That is the reality as well. In a lot of instances, you just need better processing, and that can come at a cost of a little bit of impact loss. So for that reason, we also complemented our portfolio with more standard viscosity modifier master batches based on these 3 types of peroxides. What are the benefits of peroxide master batches over neat peroxide? It's very simple. It's safety and handling and just pure dosing accuracy. Neat peroxides are a very difficult and hazardous material to store on site. Dosing them correctly is quite challenging, not for all, but for a lot of recyclers it can be very challenging. So using it in a master batch form does create a lot more simplicity for the user. And then we added a few new materials to our portfolio based on the Trigonox 501CS40 peroxide. Why? This type of peroxide has a better VOC, so the volatiles are much lower, and you have improved organoleptics. That might sound a bit contradictory since you are using it in PCR polypropylene, but we do see a trend towards more highly purified polypropylene grades coming out of PCR for cosmetic packaging, even towards food grade applications at some point in life. And that's when we believe it will also be an added value. That was what we can do in polypropylene. I'd like to finalize the presentation with a short case study on a project we did with a customer on the injection molding of recycled AZP. We worked here with a customer who was very active in more heavy-duty reusable packaging, especially on the crates. That was what we were working on. This is a company that was already doing quite a lot on recycled content, very well advanced in that aspect. So 100% our AGP formulation was already running. So then the question was more, okay, what's next? What's next for this part? And that's when we started testing our ultra-fast master batch with them. And we were able to basically keep that 100% RPE formulation, but significantly decrease the cycle time. So more than 10% reduction in cycle time while using 100% recycled polyethylene and just producing faster with a lower energy consumption. So again, not just looking at how can we use more recycled, but how can we do more and better with that recycled content. That was a lot in a very fast rate, in my opinion. So if you have any questions, please feel free to shoot. If you want to talk in more detail, then you are more than welcome to visit us there in that hall. Thank you. No? So I'll split it out into the three products that we discussed. The DeltaMax technology is really designed for more heavy-duty impact requirements. So that is a non-food contact approved additive on its own. So as a result, it will not, yeah, exactly. The peroxide master batches can be food contact approved if needed. We can offer a different portfolio for that. And then the final one, the ultra fast, is also food contact approved. So it can go into all approvals basically. Normally the reaction is completed in the first pass. So if you take it from a 10 ml flow to a 60 ml flow, it will remain a 60 ml flow in the recycling step. It will not go back to its original state. It will not react further. It's from then on forward, it is a higher melt flow material. Okay, good. Thank you all.